Café que te encanta y que con su canela cada mañana te levanta. Chocolate que se bate al ritmo que tu corazón late. Ingredientes que se mezclan y hacen del sabor nuestra fortaleza. Cielito, querido café, sabe a Cielito.
Hi, good morning. We are Team 3 and we're going to talk about Cielito, querido Café. For the introduction, we have that this is a Mexican specialty coffee chain that it's combining tradition with modern branding. As well, it's known for the café de olla, chocolate, atole, and Mexican pastries like conchas. It has a strong visual identity, colorful, nostalgic, and culturally humorous. It was acquired by Grupo Herdes in 2019, continuing its expansion in major cities, and it differentiates from competitors by selling cultural experience and not just only coffee.
Now I'm going to talk about the small medium enterprise characteristics of the store we analyzed. According to the Mexican Small Medium Enterprise Classification or the Micro Pequeñas y Medianas Empresas de México, this business fall under the category of a small enterprise, which typically means having between 11 and 50 employees. In this case, Cielito Querido Café, the operational structure of a single store usually includes one store manager, 2 to 3 shift supervisors or senior baristas. This gives us an estimated headcount to 12 to 15 employees for the store we are evaluating. Now, regarding the financial and operational performance of a typical Cielito Querido Café location, we use chain averages along with the Mexican Coffees Market CAGR, which ranges from 5.9 to 7.1%. Based on these trends, a single store is estimated to generate between 5.5 and 7 million pesos in annual sales.
For our target market, we have the age of 18 to 39 years. This overlaps with the fastest growing segments in the Mexican specialty coffee market, where people from 18 to 24 is the largest revenue generating age, and the group from 25 to 39 is the fastest growing segment. For the profile, we have that we could have customers such as university students and young professionals, office workers from surrounding corporate offices, shoppers nearby malls or commercial corridors. For the psychographics of our target market are people that value experience and aesthetics, such as Instagrammable spaces, branded cups, colorful visual identity, etc., as well also the high interest in premium specialty coffee, Mexican cultural references, and nostalgic flavors. For the occasion of consumptions, we have that the most current times is morning commute and breakfast, midday coffee snack break, and in the afternoons, since they also have informal meetings, study sessions, and remote work.
On the problem, the main issue we identified is inefficient inventory and production planning. This problem generates two opposite but equally damaging outcomes: the high waste and frequent stockouts. For example, pastries, dairy, and prepared drinks often expire or remain unsold, while at the same time the store regularly runs out of key products during peak hours like 8 to 10 a.m. and 4 to 7 p.m. These inefficiencies leads to lost sales, frustrated customers, and a stressful reactive work environment for the employees. So overall, the store faces necessary financial losses and operational instability simply because inventory and production processes are not being managed with an accurate data.
For the root causes for this problem is that no POS data exploitation. POS is the point of sale, as well no forecasting process, low digitalization typical of Mexican medium small enterprises, under supported manager autonomy and fragmented systems.
On our current ASIS process, we look at how the store currently operate or how it is processed. And right now, ordering is not based on any formal forecasting system. Instead, managers rely on experience, basic notes, or last week's sales to decide how much they will order. This is no SKU level analysis from the PO system. Production happens in fixed morning batches with no real-time adjustments through the day, and there are no rules for display times, no freshness controls, and the team doesn't follow structured bake cycles. Monitoring is also very limited with logged generically without SKU detail, and there are no dashboards or analytics to help managers understand patterns. Finally, the decision making is reactive rather than data driven. There are no alerts, no forecasting tools, and baristas make decisions based on melee and heuristic order intuition. All of this creates an operational process that is slow, inconsistent, and disconnected from actual customer demand.
For our economic impact, we have that operational speaking, there are stockouts at peaks from the morning at 8 to 10 a.m. and in the afternoon from 4 to 7 p.m. As well, there is an excess of the products at the end of the day, and there is also barista overload in rush hours. For our financial impact, we have that we have a waste from 216 to 288K each year, also lost sales from 459 to 612K for each year, and a combined loss from a 10 to 15% of annual revenue. And we're going to present the management information solution that it will be the inventory and purchasing model.
Well, on the inventory and purchasing management model, to solve these inefficiencies, we propose implementing an inventory and purchasing management model integrated with the POS system. In this model, directly addresses the root causes we identified. It introduces demand forecasting, provides a real-time stock visibility, and eliminates manual ordering, such as improves production planning, and creates accurate waste tracking. Every sale recorded in the POS will automatically deduct inventory and update stocks levels in real time. The system will also analyze hourly, daily, and seasonal sales patterns to suggest optimal order quantities. It even supports creating efficient production plans by recommending morning batch sizes, midday rebakes, and medium display times to avoid over or underproduction. Finally, this model equips managers with dashboards and KPIs like subsellers, slow movers, the waste percentage, and forecast accuracy. In short, this model transforms inventory and production planning from intuitive guesswork into a structured data-driven system.
We think it's the best fit since Cielito, Querido Café's biggest operational weakness are in these areas of inventory, purchasing, and production planning, and not marketing or not human resources. We have for the track inventory in real time, it will help since every sale at the point of sale, it will be automatically deduct the stock and update the inventory levels. As well for the automate purchasing, the system calculates optimal order quantities based on the past sales and forecast. For the use of demand or forecasting, the day of the week patterns, hourly sale patterns, seasonality, product level trends, and then it generates suggested replenishments. For the build efficient pastry production plans, we have that it will recommend morning batches, midday rebake suggestions, max playtime rules to avoid overproduction or underproduction. As well, it will provide dashboards and KPIs. Players get real-time visibility into top sellers, low-moving SKUs, waste percentage, stockouts, forecast accuracy, and order frequency.
Then why not other models? We evaluated additional MIS models, but none of them solve the core operational problem faced by this cafe. Our management model is necessary because Cielito Querido Café is a single store, not a distribution center. A CRM model focuses on customer loyalty and marketing, but the store's main challenge isn't generating demand. It's managing demand correctly. An e-commerce model isn't relevant either because the case does not involve online sales or delivery issues. And an HR model doesn't address production planning, forecasting, or inventory efficiencies. Therefore, the inventory and purchasing management model is a more strategic and effective solution. Now we have our ASIS modeling. In this model, show how fragmented and efficient the current process is. Inventory and production planning depends mostly on intuition, manual records, and isolated spreadsheets. The store does not use POS data to support ordering, which results in inaccurate estimations. Stockouts happen because there is no forecasting, and waste accumulates because production is not adjusted through the day. Information is scattered across notebooks, verbal communication, and Excel, making it very difficult to maintain consistency or accountability. Overall, decision-making depends heavily on manager experience rather than analytics or standardized rules, which creates bottlenecks, inefficiencies, and operational volatility. This ASIS model clearly highlights why a digital MIS solution is necessary.
This slide shows what the future process will look like once the inventory and purchasing management MIS model is implemented. Right now, the cafe heavily relies on human intuition. With the new POS, sales automatically update inventory in real time, so the team always knows exactly what's in stock, providing daily and weekly demand forecasts for each SKU, helping the cafe prepare for peak hours and avoid shortages. The MIS generates automatic reordering suggestions based on stock levels and consumption patterns. It also supports an automized pastry production schedule, splitting production into morning and midday cycles to match the real demand. Waste is no longer written in notebooks or ignored. Instead, every waste event is recorded, analyzed, and included in reports. Managers receive dashboards, notifications, and alerts that replace intuition-based decision making. Overall, the 2B process eliminates issues like stockouts, overproduction, late ordering, and replaces them with accurate and efficient operations. So in this first group of MIS function requirements for the new inventory management system, starting with the POS inventory integration, the system will automatically update inventory every time a product is sold. This helps us see real-time stock levels, get alerts for low inventory, and keep both online and in-store data synchronized. Next, we have the demand forecasting and analytics. This uses statistical models to predict trends like peak hours, seasonal changes, and promotions, so the cafe can better plan for busy times and avoid running out of key products. For automated purchase and replenishment, the system calculates how much stock should be reordered based on usage, supplier lead times, and minimum stock levels. It can also generate purchases orders and send them directly for approval. Finally, the pastry production planning helps the cafe prepare enough pastries for the day without creating waste. It adjusts production levels based on real-time sales and alerts staff when they're under or overproducing. Overall, these features work together to improve accuracy, reduce waste, and keep the cafe well stocked during peak demand. Now here we have the waste logging and cost analytics. The system tracks waste by SKUs, meaning it records what item is wasted, how much, and why. It then calculates the cost of that waste and shows trends so managers can reduce unnecessary losses. Next is inventory management and reporting. This includes detailed reports on fast and slow moving items, expiration date tracking for perishables like milk, and a variety of reports. For managers, the system includes a decision support dashboard that gives them daily KPIs like stockouts, forecast accuracy, waste percentage, and sales trends. It also highlights unusual events and sudden spikes in demands. Finally, we have technical requirements. The MIS is fully integrated with the existing POS system, supported cloud access, and have user permission controls. and include strong data backup and security. It should also allow future expansions through AIPs. Together, these requirements ensure the system is not only operating usefully, but also secure. On this slide, we summarize the financial values of implementing the system. The cafe currently loses money through spoilage, stockouts, and manual labor time. By switching to this digital inventory system, the cafe could recover between 385,000 Mexican pesos and 550 to 200,000 per year in benefits. Meanwhile, the annual cost of the system is only around 30,000 to 45,000 Mexican pesos. This gives a project a very strong ROI of 600%. We also look back at the payback period, which is how long it takes to recover our initial investment. Since the cafe saves between 32,000 to 46,000 per month, the system pays for itself in less than a month.
On, on this slide, we introduce the EIS design and implementation plan, which is a part of the retail ERP MIS specifically adapted for food and beverage operations like Cielito, Querido, Café. We propose a cloud-based retail management information system integrated as an ERP. This tool centralizes and automates all core processes: POS data capture, inventory recording, demand forecasting, purchasing, production planning, and customer relationship management. By integrating these areas, we create a unified system that supports better decision-making and eliminates the manual gaps that currently affect the store's performance. Next, we outline the non-functional requirements for the MIS. This defines how the system must behave in order to be reliable and efficient. Starting with security, the system protects the operational data that will later feed into the AI model. This includes role-based access to baristas, shift leaders, managers, and accountants. Each have appropriate permissions. Authentication controls such as strong passwords and optional multiple-factor authentication improve protection. All data is encrypted, and we maintain a full audit logs for any stock adjustment or purchase orders. Moving on to usability, the system must be easy for any employee to use. This includes a mobile first and touch-friendly interface, color-coded indicators for stock levels, and simple workflows for deliveries, spoilage tracking, and ordering. The dashboard highlights low stock items and incoming deliveries, and the system offers both Spanish and English language support. Performance is essential for cafe operations. We need a fast, stable performance with real-time POS to MIS updates in under 1 second. AI-generated forecasts should be available in less than 10 seconds. The system should also support hundreds of daily transactions and maintain 99.5% uptime. Finally, scalability. The solution must support future growth, allowing the cafe to add new SKUs or seasonal products, scale to multiple stores, and benefit from automatic cloud updates and backups. This ensures long-term sustainability. For the implementation timeline, we present a 4-week adoption plan for the MIS and AI integration. Week 1 focuses on system setup. We import SKUs, suppliers, and historical data. We define roles, configure minimum stock levels, and integrate the POS with the MIS. By the end of week 1, the test environment should be fully operational. Week 2 is a training phase. Staff learning their specific tasks, baristas log spoilage, shift leaders confirm deliveries, and the manager learns how to use forecasting and inventory reports. During this week, the system is used in a limited control manner. Week 3 is a parallel operation phase. Here, the MIS and manual processes run simultaneously. AI forecasting is active, but the store does not rely on it yet. This period helps identify discrepancies and refine the model before full deployment. And finally, week 4 is full go live. The MIS becomes the primary operational level. AI-generated reorder recommendations are used daily, and the team monitors performance while receiving vendor support as needed. This structured timeline ensures a smooth transition with minimal operational risk. Now we move into the technology and architecture. We selected a cloud-based architecture for several reasons. First, cloud solutions eliminate the need for physical servers or specialized IT staff, which reduces the cost and complexity for a small business. Second, cloud systems allow remote access from any device, providing full flexibility for managers and staff. Cloud-based ERP systems also scale easily as the cafe grows. Whether that means adding more SKUs or opening additional store locations, the system benefits from automatic updates, built-in reliability, and frequent backups. Overall, this architecture results in lower upfront costs, greater flexibility, and faster integration, making it the best option for a food and beverage SME like Cielito, querido Café. This slide explains the rationale behind using AI. The main operational challenge we identified are stockouts and spoilage caused by unpredictable demand. Cafe items, especially pastries and milk-based products, have short shelf lives and vary daily in consumption. Manual forecasting is unreliable because human intuition cannot identify deep demand patterns. AI also solves this issue by learning from historical SKU level sales data, recognizing patterns humans cannot detect, and predicting demand more are likely to expire before being sold. Third, reorder optimization by suggesting the ideal quantities the store should purchase. The integration between AI and MIS is essential. The MIS provides the sales, inventory, and supplier data, and the AI returns optimized decisions directly back into the MIS for the manager to approve. Now we have to outline the data for the data required for the AI models to work effectively. AI needs several categories of information, all of which the MIS captures automatically. These includes POS, sales history, inventory levels, spoilage, reports, and delivery records. AI also relies on supply information such as lead times and reliability. Product shelf life and minimum order quantities are important outputs for predicting spoilage and optimizing orders. External data also helps improve accuracy. This includes weather patterns, which affect beverage consumption, and holiday calendars, which influence customer flow. A minimum of 12 months of historical data is ideal for training the model. Once the model is trained, it generates several outputs: forecast demand for the next 7 to 14 days, optimize reorder quantities, spoilage risk alerts, and early stockout warnings. Managers then approve or adjust these recommendations directly within the MIS. Better stock availability, and labor savings. The total cost of ownership for 3 years is estimated between 72,000 and 90,000 pesos, depending on subscription level and support requirements. Over 5 years, the investment ranges between 118,000 and 170,000 pesos. The return on investment over 3 years is approximately 183%, and the payback period is just over 1 year. After that point, the system becomes a source of continuous financial gain for the cafe. And that will be it for our presentation. If you have any questions, let us know. Thank you.